All right, so here are the notes for section 4.4, the graphs of sine and cosine, or sinusoids. So we've got here sinusoids and transformations. So first, the definition of what a sinusoid is. A function is a sinusoid. It can be written in the form f of x equals a sine x, or a sine of bx plus c plus d, where a, b, c, and d are constants, and neither a nor b is 0. Now, if a is 0, you just get f of x equals d, which is a straight horizontal line. If b is 0, you also lose the x value, so you also get a straight horizontal line. So they're called sinusoids because they're based off the sine function. So definition, we've got the amplitude. So the amplitude of a sinusoid, a sine bx plus c plus d, is absolute value of a. Similarly, the amplitude of a cosine function is also a. Graphically, amplitude is half the height of the wave. So if you think about your graph of a sine function, for example, the amplitude is that amount, or that amount. The second part here where it says half the height of the wave, that is, so that distance is 2a. The amplitude is from the center line up or from the center line down, not top to bottom. So be careful with that. All right, so example 1 asks us to find the amplitude of each function, use the language of transformation to describe how the graphs are related. So this graph has an a value of 1, so the absolute value of a is the absolute value of 1, so the amplitude is just 1. For this one, a is 1/2, so the absolute value of a is the absolute value of 1/2, whoops. So your amplitude is just 1/2. So this graph would be a vertical stretch of 1/2, or compression. So here, a value is -3, so the absolute value of a is equal to the absolute value of -3, so my amplitude is just 3. Transformation-wise, this is a flip, or a x-axis reflection, and a vertical stretch of 3. So the negative sign flips the graph just like it always does. The 3 controls the stretch. You also can talk about what's referred to as the period of a sinusoid. The period of the sinusoid is given by 2 pi divided by the absolute value of b. So the period is the length of one full cycle. So if I look at my sine curve again, so it just also continues going on forever. The period runs from here to here. So that is the period of the sine function. Now, the other thing that messes some people up on the period is that period is not start at 0 back to 0. Your graph has to complete a full cycle. So this is at 0 going up, so I have to go back to 0 going up. So this is where the repeat starts. The repeat doesn't start here. And our formula is 2 pi divided by the absolute value of b. Okay, so example 2, find the period of each function. So periods essentially are horizontal stretches or compressions, because they're going to, a long period is going to stretch the graph out, a small period is going to compress the graph down. So this one, my b value is 1, so the period is 2 pi over the absolute, over the absolute value of 1, which is just 2 pi. So this one, my b value is 1/3, because you have to write b as a coefficient on the x. Dividing by 3 is the same as multiplying by 1/3. So the period here is 2 pi over the absolute value of 1/3. To divide by a fraction, you invert and multiply, or keep, change multiplication, and flip. So the period of this function is 6 pi. So this is a horizontal stretch of 3. Remember, horizontal things do the opposite what you'd expect. It looks like you're dividing by 3, so it should get smaller, but just like horizontal shifts left-right, horizontal stretches or compressions do the opposite of what you'd expect. So this one, my v value is -2, so the period is 2 pi over the absolute value of -2. So let's see here, this would be 2 pi over 2, which is just pi. So this is a horizontal compression of 2. or a stretch of 1/2, if you want to think about it that way, the reciprocal. It's also a y-axis reflection because of that negative in front of the 2. So this graph will be mirrored left to right and compressed. Related to the period is the frequency. The frequency is b over 2 pi. It's the reciprocal of the period. So the period tells you how long a wave is. So length per cycle, and then this one gives you cycle per length, essentially. So find the hertz is the measurement for this, like how many waves pass a given thing per second. So whereas normally wavelength is measured in distance, frequency is measured in per seconds. Find the frequency of this function. So for this problem, b is 2/3, because 2x over 3 is the same thing as 2/3 x. So absolute value of 2/3 over 2 pi. So this will become 2/3 times 1 over 2 pi, which is 2 over 6 pi, or just 3 pi. Whoops, 1 over 3 pi. So there we go. And if you actually calculate the period, you'll get 3 pi. Now, so you have all the regular transformations for regular graphs. You can stretch, compress, flip, or y-axis reflect, x-axis reflect. You can move the graph up or down. Horizontal translations for sinusoids have a special name, though. They're referred to as a phase shift. They move the graph left or right, or phase shifts. So example 4, write the cosine function as a phase shift of the sine function. So let's look at the sine function first. So the sine function looks like this. The cosine function looks like this. So if you notice, my peak is here, which is actually at pi over 2, and this one has its peak here at 0. So I need to move this point left pi over 2 units. So the cosine is the same thing as the sine function, shifted left pi over 2. Now remember, for horizontal translations, the opposite of what you'd expect. So even though I moved the graph to the left, I had to have a plus pi over 2 there. Actually, now that I think about it, I feel like I may be explaining that backwards. No, I was right. So sine function as a phase shift of the cosine function. So we're starting with cosine, which looks something like that. And we're going to the sine function. So it's the opposite thing. This point here is moved to the right. So the sine function is the cosine function shifted pi over 2 units to the right. But it's the opposite of what you'd expect, so minus pi over 2. Now, going to graphs. So these are the functions you have for the graph. If you notice, there's this nested set of parentheses here. So you have to be careful. Your h value, you have to essentially factor b out. So if you see something that looks like this, the sine of 2x minus 10, your h value is not 10. You actually have to rewrite this as the sine of 2 times x minus 5. You have to factor out that coefficient. This has a horizontal shift of 5. So please be careful, because that's a really easy thing to miss. And then it gives you the summary kind of breakdown here. So we've talked about amplitude is the absolute value of A, period is 2 pi over b, the frequency is the reciprocal of that, then your phase shift is h, your vertical translation is k. So it says construct a sinusoid that rises from a minimum value of 5 at 0 to a maximum value of 25 at x equals 32. So I need to figure out my amplitude, I need to figure out my period, and I need to figure out any translations that I may have. So let's see here. So, whoops, wrong place. So we know our minimum value is 5 and our maximum value is 25. So our amplitude is half the distance between those numbers, because it's half of the wave height. So this wave goes from 25 to 5, so the height is that divided by 2. So the amplitude is 20 over 2, which is just 10. To find the value for b, I need to figure out what my period is. Well, my minimum value is at 0. My maximum value is at 32, so that's half of a wave. So from 0 to 32 is half of a wave, so my period is actually 64, and that's equal to 2 pi over b. So 64b is equal to 2 pi, so b is 2 pi over that, so it is pi over, whoops, I'm off the screen, 32. So that's the period of my function. Now, to build our thing, so that rises from a minimum value of y equals 5. So this starts at a minimum. So what we actually need to do is we need a graph essentially that does something like, that does that. Now, starting at a minimum or a maximum is actually a feature of the cosine. The cosine function either looks like this, if a is positive, or can look like this, if a is negative. So since we're starting at a minimum, we need a cosine function. So we're going to have negative 10 cosine. And so I want to start at a minimum or maximum, so I'm going to use cosine. If you start at the center, you'd actually use sine. So then we would have pi over 32 x. Now the problem with this is this graph runs, has a minimum at negative 10, but I need my minimum to be at 5. So I need to move the whole graph up 15 units. Because normally, if you don't shift this vertically, your minimums and maximums are whatever this coefficient is. So this graph, without that 15, would have run between negative 10 and positive 10. But I need to run it between 5 and 25, so I need to shift that whole graph up 5. The other way to do that would be you could plug in, leave that as a variable, leave that as k, plug in 0 for x, so you have 5 equals the y value, because this is y equals. So you'd have 5 equals negative 10 cosine, blah, 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 times 0 plus k, and you could actually algebraically solve for k if you didn't want to think your way through the problem. Okay, now the last one is kind of an application for word problems, modeling. So constructing a sinusoid model using time. So determine the maximum value capital M and the minimum value lowercase m. The amplitude A of a sinusoid will be the difference divided by 2. The vertical shift will be the sum divided by 2. So actually in that previous problem, I could have found k if I took, if you take 5 plus 25, the minimum plus the maximum, and divide it by 2, that's 30 divided by 2, or 15. To determine the period p, the time interval of a single cycle of the periodic function, the horizontal shrink or stretch will be b equals 2 pi over p. So we need to figure out how long it takes this to repeat. And then you choose one of these 4 versions, depending on what you're doing. If you know it attains a maximum value, you're going to use the positive cosine. If you need it to attain a minimum value, you're going to use a negative cosine. If it's halfway between a minimum and maximum value, these two, so between a minimum and a maximum, and you're going down to up, you'd use this one. If you're going up to down, you'd use this one. Okay, so example 6. On a certain 4th of July, high tide occurred at 9:36 a.m. At that time, the water at the end of the 61st Street Pier was 2.7 meters deep. Low tide occurred at 3:48 p.m., at which time the water was only 2.1 meters deep. Assume that the depth of the water is a sinusoidal function of time with period of half a lunar day, 12 hours, 24 minutes. So the first thing we actually need to do is we need to convert our times into all hours or things like that, because we need to count essentially can't count in minutes, or sorry, hours and minutes. So 9:36, to convert minutes, you divide by 60. So this is actually 9.6 in terms of just hours, 9.6 hours after midnight. 3:48, divide the 48 by 60. So this is 48 over 60 is 4/5, so that's 0.8. The trick here, though, is this is PM, so I have to add 12 to it. Essentially, I'm doing kind of a military time here, so this is 15.8 hours after midnight. And then my 12 hours and 24 minutes for the period, divide 24 by 60. The period, is actually 12.4 hours. So that's everything in terms of hours. Okay, so determine the amplitude. So A will equal max minus min. So high tide, maximum value minus minimum value divided by 2. So that's 0.6 over 2. So my amplitude is 0.3. The vertical shift, C, is going to be the sum, 2.7 plus 2.1, divided by 2. So that's 4.8 over 2, which is 2.4. Okay, and the value for B is 2 pi over my period. So 2 pi, my period, it gives it to me, the period of half a lunar, so 12.4, so this is pi over 6.2. So now I just need to fill in the values. The only thing I'm missing is this capital T. So we start at a high tide maximum, so I'm going to use, this version. So let's see if I can get it. No, I can't get it all on the screen at once. So it's A, which is 0.3 cosine, parenthesis, B, pi over 6.2, parenthesis, T minus. Now, this time T here is when my maximum occurs. So it's 9.6. So T minus 9.6, and then plus C, which I found was 2.4. So this equation will give me the height of the water at any time. Essentially, I'm measuring my time starts at midnight. So if I plug 9.6 in, this becomes 0. The cosine of 0 is 1. I get 0.3 times 1 plus 2.4, which gives me my maximum height there. So this is your equation, just working through these steps. The trickiest one here is figuring out that value there, the capital T value. But that given time, it'll be given to you somewhere. So if you have a maximum at T, you'd use this. So I knew I had a maximum at 936, so I had to convert 936 this is my capital T value. This one here I actually didn't need. So, but I calculated anyway, just in case it would have come up. You could have done this one, negative A, if you'd used the 15.8, because that's a minimum value. And that, though, brings us to the end of this section.